little story this time, and I love stories. But before we get into that, let's start a little bit with who exactly this madman is up in front of you speaking. So, oopsie, we shall go backwards. Okay, I guess we're not doing that. Yes, back. Okay, so my name is Brandon Weaver, and you see, I started as an artist, so I like to illustrate things like that avatar up there in this entire talk. And it started with someone saying, you know, you should try web design. It's a little bit more profitable. It'll get you a bit more reception. So I tried it, learned some HTML, CSS. It was a good time, maybe not in CSS, but we endeavor. And then they said, you know, maybe add some JavaScript. How about some JavaScript? That'll make you more effective. Okay, so I had some JavaScript, and then someone said, how about a backend? And it went very far downhill from there. So far downhill, in fact, that I ended up becoming a frameworks engineer over at Square, where I'm currently working as a Ruby architect. But that's not why you're here. You're here for a story. And oh, I have a story today for everyone. So, shall we get started? Our story begins. So our story begins with young Red and his master Scarlet. You see, Red's studying diligently when his master comes in and informs him that she's going to be leaving. Now, Red, I'm going to be leaving. The Council of 3.0 has called, and I'll be gone for a bit. So be sure to study your hardest for the test, because I'm going to have it as soon as you get back. So with that, Scarlet left, and Red made sure that she had actually left, because Red's a mischievous little lemur, and he has some very, very bad ideas. You see, my esteemed audience, in the castle of Master Scarlet lie secrets, forbidden corridors, libraries, knowledge unseen and untold for generations. And Red was going to find a few of those. So down he went, down into the depths of the castle, where the candlelight faded to blackness and where all light seemed to vanish. And there, at the very end, he found it, a massive door wrought from steel and locked tightly, a door he'd often dreamed of opening, and a secret only whispered in the halls of the castle. Great and terrible knowledges lay beyond that door, perhaps even the secret to masterhood. With that power, Red could become a master, and studying would be a thing of the past. Tests would be a thing of the past. I mean, after all, masters don't need to study, do they? But the door, it opened at his touch, as if inviting him in. Surely it was a sign of divine providence. So Red entered, and in that hall he found a vast library, the likes of which were unmatched in the land of lemurs, dwarfing even the grandest city libraries of the Master Violet. Knowledge beyond knowledge, and at the center he saw it. The Book of Legends, a grimoire of infinite power and possibilities, a dark manuscript whispered in the histories of lemurs, rumored to contain horrors and wisdom beyond the capacity of a normal lemur. But Red was no normal lemur, so this was absolutely fine. So with the book in his hands, knowledge would soon be his, so he took a moment to savor his triumph. And he opened the book, and on it he found words he didn't quite understand, but then things started getting stranger. The words seemed to blend together on the page, and everything seemed to fade. And something changed in the air. The room grew suffocating, and the words on the page faded, disappearing and running in the fog. The fog glowed in angry red, and on the page a new phrase came. Welcome to the Ruby Grimoire, and thank you for freeing me, young one. Freeing? What does it mean, freeing? And then a new phrase came onto the page. Behold the Dark Lord Crimson. The pages wrote out as if in reply, and Red looked up, and what he saw standing there, a specter, a malignant being, swirling red fog, and the Dark Lord Crimson was free, and all Red could do was scream. Well, for a moment at least. You see, I like fun stories. That's a little bit horrific, so let's get back to the fun part. Keep it down, no need to be rude. I can't see a thing with that lamp, and it's been a while since I've had visitors down here. Red stared back in stupefied horror. Ah, the grimoire! How long it's been since there was a lemur that actually bothered to open it? Welcome, so long indeed. A seeker of knowledge is at last. How exciting this is! What lesson should we learn first? What arts can we attempt? What stories to be told? So much possibilities indeed. Tales of lands beyond the ripple into the deep shells of languages old and new alike. Power beyond your wildest imagination, all written upon these pages. But I must ask, young one, are you willing to pay that cost? Red, poor Red. He was transfixed and started nodding vigorously. You see, there were knowledges here beyond him, and knowledges he would learn no matter the cost. These make very convenient water breaks. The true nature of the grimoire. The grimoire is a journal of my journeys into land beyond rubies, where I met several wise ones beyond me or anything I'd ever seen before. And of all the tales to be told, we shall start with 3 and some of my personal favorites. Tales of the Lemurs of Scala, of JavaScript, of Haskell, each bearing knowledge beyond what I'd imagined. And we'll take a glance at each today. The Lemurs of Scala. We shall first learn from the Lemurs of Scala. The Lemurs of Scala wear conical hats, spires to the heaven, cloaked in robes that change colors and styles as often as they change the way they program. Where Ruby has flexibility, Scala has so much more. And the lessons they bring us give us insight into those flexibilities. They bring with them arts of closures and a spell known as a placeholder argument. Placeholder arguments are when an underscore can act as a shorthand for arguments to a function. Now, you might know this from Ruby. It's something more like this. But what if perhaps we could do the same thing in Ruby? Now, before we can perform such clicks, we're going to need to know a few little tricks. Consider with me a function, a lambda, which takes an argument A and returns a function which takes an argument B. Now, why would someone do something like this? Well, the outer function takes in a value A. And the nifty part about these functions is that when that function is returned taking an argument B, where do you think it gets that A value from? Notice, A is currently visible to the returned function, so it remembers the value of A. This is what we call a closure. It remembers the context, where it was created. Or rather, it remembers whatever it can happen to see around it. Now, why is this useful? Whenever we call adds with 1, it remembers that value at 1, and we can call add 1 right afterwards with the value of 2 to get back 3, remembering that 1 from above. So why, again, is this useful? Well, let's say that we put that in a map expression. Using ampersand, which is toproc, we can add 1 to every element of a list by this. Or, because we can substitute, we could just inline this code and call it directly like that. But if we wanted to, we could even make it more succinct with square brackets being equivalent to call, but that's short and confusing, and we'll prefer longhand from now on. But how does that get us closer to placeholder arguments? Well, how does a plus operator work in Ruby? This is the source. Oh, I see some people with very bad ideas out there. Great, I have several of my own. This is why I'm giving this talk. So how does Ruby know to add 2 numbers? Well, as it turns out, there's a secret there. It's no more than a method call. And we can define methods. And it looks something like this if you squint hard enough and pretend C code is Ruby and leave out a few more details that are not important to the sake of this explanation. Red stared with a doubtful expression at this. What? What? It's a lesson, not an exact science. Anyway, moving on now. With these 2 tricks, we know enough to make our own placeholder arguments. We just need a little bit more Ruby magic, and we'll be able to dance a fine Scala dance. So remember our integer class. What if we made our own class that had a plus defined on it? We can call it parg for placeholder argument. And we'll leave it red because it acts just like the left side of the function, which we'll see in a moment here. Now, here's another fun trick. There's nothing that says you can't define plus on the singleton of a class. Now, why, you might wonder, would you want to do this? Because that means that you can do something that looks like this, and that works. That's very valid, Ruby. We can call plus directly on the class. So if we do that, we can use our lesson on closures to perhaps return a function instead, because there's also no rule on what it needs to return. So we could just do something like this. And oh, people are starting to get bad ideas. Yes, yes. Great, magnificent, I love bad ideas. So this brings us to a very interesting thing in Ruby I discovered. ToProc applies after infix operators. So we can do something like this, which applies ToProc on that function that we just returned, allowing us to get something which looks very much like Scala, doesn't it? Or if we're particularly naughty lemurs, we can always redefine underscore. Now, this, of course, can do bad things, but we wanted to prove a point, so we're going to do it anyway. Now, imagine with me that we write the rest of the possible operators. Maybe we use method missing to allow it to use any other function, or perhaps respond to find out if it can even do that. Or if we're really, really into it, we could even make this into a stack builder and do something along the lines of, say, underscore plus 1 double equals 2. And we could add these operations and have them reduce onto a stack and all the magnificent things we could possibly do with this. Imagine the possibilities, but that's a tale for another day, a later chapter in the Grimoire. Of dark magics. So Red stopped as they walked, and he had to ask, but aren't these dark magics? It feels like we're just doing bad things to language for doing bad things to language. Why would we want to do that? Oh, come now, you're not one of them, are you? Some would call these dark magics, where I would simply say we're exploring the possibilities of language. Imagine the use of such thing and how much more powerful Ruby might be with it. They might even merge it into Ruby core one of these days. So Red nodded, suitably convinced, and they moved on. The Lemurs of Javascript. Now, in my journeys and a land not far from this one, I found the Lemurs of JavaScript. Fascinating masters with lessons more fascinating indeed. The Lemurs of JavaScript were fashionable with all forms of accessories, colors, designs, decorations. Why, they could even change the very language which they communicated with by using different jewelry and accessories and packages in this most wonderful system, which I'd very much like, called Babel. And they bring with them an art of destructuring beyond that which we know in Ruby. It allows them to pull values out of objects by name. So say we had a move north function which can extract the x and the y values from the object passed into it. And this is known as an art of destructuring. But what exactly is that doing? You see, inside this function, the value of x is 1 and the value of y is 2 because it extracts those values from that object that's passed in. So we can use those values to add 1 to y and make it move north, as it were. But there's another magic in JavaScript, and one I have not found a way to emulate, no matter how much I might try, known as punning. And of course, we love punning in Ruby. Yes, several famous Rubyists love punning. But this type of punning is different and beyond us, and we have to ask at what cost would it be added to Ruby? Now, this allows us to make a new object with x unchanged and y with 1 added, but an art for another day, namely after I can figure out how to make the thing work. Fine. Anyways. We can do destructuring in Ruby, but first, we must learn the art of extracting arguments from a proc, and yes, you can do just that. Say we had a function fn, the body doesn't matter, just that we have the arguments x and y. Empty for now, because yes, only the arguments. Now, there exists a method called parameters on a proc. It returns back an array of pairs, the first being the type and the second the name. So if we were to map the last item of each of those, we have the names of the function arguments. And oh, there are fun things we can do with this. Now, this is all we need to make our own idea of destructuring. If we know the names of the arguments, we can use them. So let's say that we have a point, a simple struct. Now, for those not familiar with what a struct is, it's something vaguely like this. Except that's a lot of code to write, and I don't like that. So let's go back to the struct. We'll keep it in mind for the next few parts. So for simplicity's sake, we'll start with the point at an origin of x of 0 and y of 0. And then we're going to make our own destructure function, which takes in an object and a block function. We can assume for now the object is our origin point, and our function will have the arguments x and y. So the first step is to get the names of the arguments that we passed in. Now, in the case of this x and this y, this would mean that arguments are effectively x and y. Now that we have those names, we can do something very bad in Ruby. We can map over those names and use object.send to extract those values using those names from the function arguments. So in the case of our origin point of 0, 0, and our function that takes an argument of x and y, this would mean that our arguments become x and y, and our values are effectively staying object.x and object.y. Or in the case of origin, 0 and 0. So both of which are extracted using those argument names we had before. Now, what do we do with those values exactly? Well, you see, there's no rule in Ruby for when you need to call a function that is passed to a method. So we can call it at the end with those values we extracted in the same positions as arguments, meaning we're effectively doing this with our origin point. So let's step back to our point in our origin. We can use destruction method on this point, passing it a block function which takes an argument x and y. Now, because it's 0, 0, this means that x inside that function is 0 and y inside that function is 0, because we've now given relevance to the names of those arguments inside this function. Now, inside this function, we could create a new point using that x and that y to add 1 to the value of y, which moves it north. Now, look how much fun that is. Now, a clever lemur might be able to redefine methods with some of those same tricks to add a destructure decorator that can tell the difference between an object passed and its expected arguments. But another chapter, I'm afraid, is beyond us for the moment. Considerations. By this point, Red was very worried and had to say something about this. But surely that's evil. Send is metaprogramming. We all know Ruby metaprogramming is the root of all evil, isn't it? Red. Metaprogramming has its uses, a vast and seldom well understood territory. Naturally, there are dangers, of course. But must one discard such power simply because it's dangerous? No. It depends on the context and the wisdom of the wielder. Evil is far too strong of a word for what is merely misunderstood and abused by those not ready for it. You're ready for it, aren't you, young Red? Yes, I do believe so. Red nodded, considering himself obviously ready for such an art, and they moved on. Lemurs of Haskell. Now, I have one last lesson for you from the wise sages of the realms of Haskell. Descendant from their ivory towers, they bring knowledges far beyond even me, but knowledges of fascinating implications that may shake the very foundations of the way we think about programming. They bring with them an art of lenses, an ability to focus on something and either see or change its value, a cannot say I fully comprehend them, but I find them fascinating nonetheless. And of course I tried to write them in Ruby. Now, lenses allow the Lemurs of Haskell to look deeply into a nested data structure and perform magics on those data without mutating them. Now, the examples they told me from the book of hackage were very confusing at first, so I took some liberties in trying to make myself understandable. Now, I cannot say I understand how make lenses works beyond they fill in a lot of the code that makes lenses work, but I may be able to explain the rest of this. So we have data of atom and point with an atom containing a point, and we make lenses for both of those. At least I assume that's what's happening there. And we create a function that moves an atom to the north and returns a new atom, presumably moved to the north. Now, the point has an x and a y and a coordinate, but what is that function doing down there? Well, let's simplify again, because it's still confusing. Now, we have a move north function, which uses the function over and allows us to execute a function over something which happens to look like or behave like a lens. And now we're saying that we want to do something over the y of a point. And over that, we want to add 1. So lenses allow us to specify a path to something and runs a function over them to get or change values without mutating the underlying object. Now, this all seems rather abstract, but you'd be surprised. You actually know of something in Ruby already which does something very, very similar to this. The method dig, which is 1/2 of the idea of a lens. The get. Now, it allows us to find a value that's deeply nested in a hash, an array, or even a mix of both. Oh yes, that's very fun. I've had very much fun with that. The thing to pay attention to here, though, is the path. And the path is a point which is very relevant to us here. With the path, we know how to get a value. Would it be that far of a leap of faith to say we could also set that value down there? The path is the basis of a lens and lets you know what path it is you need to focus on or look at, or lenses like glasses or scopes or something like that. So if we wanted to try and apply such a thing to Ruby, it may be difficult, but I believe we can come close. So for the sake of this exercise, we can assume that we have a set of hashes, all with the nested A, B, and C, with the values being 1 through 5. And we'll use this to demonstrate. And we can start with the idea of capturing a path in a class we call scope. See, it even sounds like a lens. We're making progress already. Now, we want to capture the path of what we're looking at in the scope. And then we want to define our own get. Now, why would we wrap this in a function, you might ask? Well, using the art of closures from before, this allows us to go over a collection and do something which looks a lot like this. So we can have a scope focus on A, B, and C, and we can map using the get of that scope to get out the values 1 through 5 of all those hashes we defined before. But to set is a little bit harder, and I had to do a few unique tricks to make this work. The first thing we need to do set is to clone the object to make sure we're not mutating it to something we don't want to. Now, this is a quick way to deep clone a hash that I happened to find on Lemur Go one day. I can't say I understand how it works, but it does, and that's good enough for me for now. Now, anyway, moving on. We start by wrapping it in a function which takes either a value or a function to transform whatever value it happens to find at that path. We start off by cloning the collection. Now, the Lemurs of Haskell are not very happy with my interpretation of mutation-free code, but it works, and it technically doesn't mutate the outside result. So we'll call that good enough for now. Then we start by getting the path we need to get to our value. Now, you'll notice that I left one of those paths off as a target key, the last key that we need to focus on. Now, why is that? Let's get into that a bit. In our initial example, we use A, B, and C, and this means that the lead-in to get to that value would be A and B, and the target key would be C, and we'll come back to why that's necessary here in a second. Now, very amusingly, to bury a value in Ruby, you would need to dig down to it in the first place, and this gives us a target location right above where it is we need to bury that value, which means that we have a lead-in of A and B and a collection of A, B, C, 1, that means that we're going to dig into that collection and get back the hash C1. Now, the next thing we need to do is decide what value it is that we're going to set there. Now, if we happen to be given a block function, we're going to yield or call that function with the value at that target location at that target key, so 1 in this case. So this would mean that we have a function of x plus 1, a target location of C1, and a target key of C, which means we've added 1 to C, and the new value will be 2. Or let's say that we didn't get a block, we could just set it to a static value, which isn't quite as much fun, but it's still useful. Now, we'll rely on a value being provided set for that static value. Now, why exactly did we want to do the entire lead-in shenanigans there? Well, if we want to overwrite that value at that location, we have to be right above it, because otherwise we cannot overwrite the value C for Ruby. We could use merge, but that's slow, and I don't like slow code. Now, the Haskell lemurs were very put off with me for this, but again, it works, so I don't tend to pay them too much mind. If we were to use this on a group of hashes, it could be used to deeply set a value according to paths. Now, imagine the possibilities here. If we were to use this on JSON or large hashes, or to use triple equals to decide if key matches or not, or if we allowed it to traverse at any indiscriminate depth of any hash by looking for a path which happens to match, it could be very interesting indeed. Now, I can't say I've written too much more on the Lemurs of Haskell because I believe they don't like me for some reason and stopped talking to me. Going beyond magic. So Red was fascinated by all the implications of Crimson's tales of possibilities and what else might lie in the grimoire. So Red had to ask, how many more tales are there in this grimoire of yours? How many more stories? How many more languages? What new tricks do you have in there? Oh, many, many more, from tribes and societies far and wide beyond all things, from the curmudgeonly Java lemurs to the mystical Lisp lemurs, all the way to the very orderly and well-dressed Python lemurs and beyond, but these were but a few of many, many tales. And there's an entire universe out there, powers beyond imagination, and so many more chapters to the grimoire to learn from. Imagine the potential if all the lemurs out there taught us all their tricks. We would be absolutely unstoppable. So the book slammed and Red turned, and what he found behind him scared him far, far more than Crimson ever had, because Master Scarlet was back, and she was not amused. So Red turned quickly, trying to get help from his new friend Crimson, just to find a sign stating good luck and a puff of dust from where Crimson had been standing not even moments before. It seemed that Crimson was also afraid of Master Scarlet for some reason. Sit. We have much to talk about, now don't we, Red? And Red broke into a nervous sweat. Proper magic. This is a dangerous book, Red, full of all forms of knowledge that you might not be ready for or know how to use appropriately. Red made a particularly intense study of his feet at this moment. You must remember, for all languages out there, you must use Ruby as Ruby. Magic can be confusing and unwieldy and difficult to control and even harder to understand for those not ready. But even given that, there are many lessons to be learned, wisdoms we may apply to the highest levels of Ruby. And language is always evolving, and we need people willing to experiment to drive its future. Consider the lesson of the placeholder arguments. Such a thing now exists in Ruby 2.7 with numbered arguments, and many more may well soon follow. What is considered magic today may very well be canon law in Ruby tomorrow. Now, there are many more tales in this grimoire and more lessons I'm sure Crimson could teach you, but be cautious and be wise in pursuing such knowledge, Red. The cost is high for using such magics in the great weaves of production you do not entirely understand yet. But the cost is higher, to pretend they do not exist at all. Now, in the meantime, I do believe I have a test ready for you upstairs. So I do hope you studied while I was gone, because I'll be giving it as soon as I get up there. And with that, Red made a dead heat run towards the stairs. Epilogue. So there behind Master Scarlet, Red hurried up the stairs in a bit of a panic. Once she was sure he left, she grinned and called out into the darkness. So, the Dark Lord Crimson, is it? Quite a title you've taken for yourself now, haven't you, dear brother? I thought you'd enjoy that one. Oh, just having a bit of fun, that's all. It's so rare I have any more visitors. You keep on knocking them out. I had to prepare a special surprise. It was such a special, momentous occasion. Can you believe it? Someone actually wanted to learn from me today. Surprise? You nearly scared the poor child out of his robes. That's not a surprise, that's horrific. Yes, well, perhaps a bit too surprising. It's been a while, and I really did enjoy getting to speak to Red. I suppose it has been a while. He's grown quite a bit since you've taken him in, hasn't he? He has, and I believe that he's finally ready for some of the lessons you and the other lemurs down here can teach him. Now, interesting you should say that. It was quite strange to see him down here, especially with that giant door you had put up in front of my library, to make sure he didn't get into something beyond him. It's almost as if someone left the door unlocked on purpose. Now, whoever would do a thing like that? Who indeed, I suppose, who indeed? So it was in the tales of Ruby Grimoire that Red the Lemur would come to know of its magics, that his master Scarlet would give him permission to study under the Master Crimson, and they would move one step closer to his own masterhood. For you see, magic is integral to Ruby, to exploring, to expressing ourselves in code beyond what's possible in many languages. And the beauty of programming and of Ruby is having the freedom to do just that. And that very experimentation can and sometimes does become a core part of the language. And sometimes it drives discussion around what Ruby should be in the future, what we should be thinking, how we should be programming, how we should be doing. But there was a cost mentioned here, and that cost can indeed be very high. It takes a lot of discretion and great wisdom to handle such magic in production, and often the simplest of code is best. And there's a special type of magic in very simple, readable, understandable code, but that's a lesson for another day. So to wrap up, and it has been fun, this talk was custom illustrated by myself with 12 lemurs, 62 illustrations, 85 hours, and about 156 slides, and a generous deal of whimsy for good measure. Now, the scary part of this talk, you thought all those magics were just me doing presentations. Oh no, oh no, no, no. Those who know me know very well that that's not true. It's real. Oh, it is very definitely real. And there are gems currently on my GitHub which do exactly that. Placeholder arguments for MF was the first Scala part that we saw. SF happens to be the stack builder. That is still a little experimental and I would not touch. It breaks a lot of things, not surprisingly. Destructuring was maxed into QO, which was also an implementation of pattern matching that I've done. And some of that ended up becoming pattern matching. And lenses are currently in something called XF, and I'm still trying to convince Matt that we need a bury function. We're working on it. We'll try. You know, I'd still be quite fond of that function, but we'll endeavor nonetheless. So if you wish to find out more about the lemurs and their next adventures, because I fully intend to make more, follow me on any of these social networks. I'll be posting slides, just examples, more. And honestly, we have to give credit where credit's due. A talk like this doesn't exist without a lot of help from the community, from those willing to entertain my mad scientist experiments, what I can only call a very, very odd form of the hallway test. Hey, you want to see something cool in Ruby? No, 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 I don't have time. Okay, well, there were those who did have time, and I thank them very much, because those mad science experiments really built up a community of people who enjoyed hacking around, having fun. You may also notice a few foxes that were hiding around in earlier slides. Well, this is because my first Ruby book happened to be written by a certain lucky stiff, and as you can see, it still influences the way I write and teach code today. Ruby needs more fun and whimsy again, so don't be afraid to submit your own wild illustrated talks, because I look forward very much to seeing them one day. And also, as with years past, we're playing a little bit of a fun sticker game again. You'll find 5 Square engineers, myself included, and yes, I have stickers up here like several other presenters. And they'll be off around the conference. I posted pictures of them with the tag Lemurs of RubyConf, so if you can find them all, send me a picture, tag it, and we have a special raffle with an indeterminate prize, which I'm still working on. That's how raffles work, right? But that's about all I have for today. So it's been fun, and thank you for allowing me to tell you this magical little story.